So far we have seen body plot and gain margin, phase margin. And then we have seen how to adjust K by using body plot. Now we are going to see polar plot and Nyquist plot. Already we know that in the S-plane, if we select a pole is enclosed by a contour. This is enclosed by a contour C. If you do the mapping on Q of S, you will get a mapping in Q plane. This plane is called Q plane. This axis is called real part of Q. This axis is called imaginary part of Q. Don't put a sigma j omega. In the S plane only it is sigma j omega. This plane is called Q plane. In Q plane, x-axis is called the real part of Q. Y-axis is called the imaginary part of Q. Here, this Q of S has one pole here. This P1 is here. I am selected a contour such a way that it encloses the P1. If you do the mapping on Q plane, it means what? Select some points on this contour and substituted in Q of S, you will get some set of points. That point is plotted here that will encircle the origin in the anti-clockwise direction. Here you select which direction you plotted in the clockwise direction. It encircles in the anti-clockwise direction. The origin is encircled. Suppose I'm having two poles inside that contour and mapped in the clockwise direction, S plane. In the Q plane, if you do the mapping on Q of S, it means substitute these points, the points on the contour in Q of S, and get some points here that will encircle the origin twice in the anti-clockwise direction. Twice in the anti-clockwise direction. This is called Q plane. Q plane, this is called real part of Q. This is called the imaginary part of Q. Suppose I'm selected a contour such a way that two zeros are there inside. If you do the mapping in the clockwise, if you select the contour in the clockwise direction of S plane, and if you do the mapping on Q plane, it means you have to substitute these points on the contour in Q of S and get the complex points. This plane is called the Q plane. This is called the real part of Q. This is called the imaginary part of Q. It will encircle the origin in the clockwise direction. Twice, because two zeros are inside. This is also in clockwise. This is also in clockwise. Suppose I'm having one pole, 1 0 inside the contour. 1 pole, 1 0. Here, the mapping will not encircle the origin. Suppose here, I'm having two poles 1 0. 2 poles 1 0 inside the contour means it will encircle the origin in the anti-clockwise direction only once in the Q plane. This is taken in S plane. Because the difference is n minus m. Always m is less than n. N minus m. How many poles inside? How many zeros inside? The difference is n minus m. P minus Q. Number of poles on the right hand side will be called as P. Number of zeros on the right side are called Q. P minus Q times it will encircle the origin. How many inside? 3. But 1 pole, 1 0 getting cancelled. That's why it will encircle the origin in the anti-clockwise direction. This is the basic concept for Nyquist contour, Nyquist stability criteria. This is mathematics. This is mathematics. This will be applied for stability analysis of control system. For that, let us take one system. To understand this, let us take a simple first order system. The first order system Q G of S equal to K upon tau S plus 1. This is the first order system. What is the closed loop transfer function? K upon tau S plus 1 plus K. For a closed loop system to be stable, poles of this denominator polynomial should not be on the right hand side. Am I correct or not? The poles are roots of this characteristic equation should not be on the right hand side. Should not be on the right hand side. Roots of this characteristic equation. The characteristic equation, how we can find 1 plus G of S, H of S equal to 0. What is that? Here in this case, H of S equal to 1, let us assume. In this case, H of S equal to 1. So 1 plus G of S, that is K upon tau S plus 1 multiplied by 1 equal to 0, or what you will get if you take LCM, what you will get? Tau S plus 1 plus K upon tau S plus 1 equal to 0. This is characteristic equation. Characteristic equation. Equal to 0 means what is the meaning of denominator? Equal to 0 means what is the meaning of denominator? It's nothing but 0. If you bring this to the right hand side, it's 0. But we can tell like this. Can we tell like this? So this numerator is roots of numerator of Q of S are roots of closed loop transfer function. Am I correct or not? If you consider Q of S directly, numerator polynomial only, not denominator polynomial. That's what I said in the previous class. Because we are not taking closed loop transfer function, we are taking characteristic polynomial, 1 plus G of S, H of S. If you take that, the characteristic polynomial is actually, we will bring this to the right hand side and we will write this only, characteristic polynomial. But I am deliberately keeping the denominator. So the numerator polynomial is the roots of closed loop transfer function. Numerator polynomial, not denominator polynomial. So I can say that 1 plus G of S, H of S equal to 0. If I consider that the numerator polynomial of this is characteristic polynomial. Numerator of this is roots of this numerator polynomial is closed loop poles. Am I correct or not? Roots of numerator polynomial equal to closed loop poles. As far as Q of S is concerned, not transfer function. If you consider transfer function only denominator polynomial, Q of S is 1 plus G of S, H of S. So, if you, from this, what we can understand is, what is the denominator? What is the denominator of 1 plus G of S, H of S? If you see the denominator of this and the denominator of closed open loop transfer function are same. Denominator of open loop transfer function and the denominator of Q of S are same. But numerator of Q of S is denominator of closed loop transfer function. So I can say that Q of S has, if you consider Q of S equal to Q of S equal to open loop denominator. Can I write like that? Because the open loop denominator of this and this are same. 1 plus G of S H of S, whose open loop denominator and G of S denominator are same. So denominator is open loop denominator. But numerator is what? Closed loop denominator. Closed loop denominator. Can I say like that? Why? Because closed loop is the characteristic polynomial. The numerator is characteristic polynomial. Numerator is characteristic polynomial. That's why it is nothing but closed loop denominator. That is characteristic polynomial. So Q of S has numerator is closed loop denominator. Denominator is open loop denominator. Open loop transfer function denominator. Open loop transfer function denominator. This is transfer function denominator. So if Q of S equal to 1 plus G of S H of S equal to what you got? 1 plus K upon tau S plus 1 multiplied by 1, that is equal to 1 tau S plus 1 plus K divided by tau S plus 1. What is open loop transfer function? G of S K upon tau S plus 1. The denominator polynomial of open loop transfer function and the denominator polynomial of Q of S are same. In other words, the denominator of Q of S is denominator of open loop transfer function. What is numerator? Numerator is denominator of closed loop transfer function. Numerator is denominator of closed loop transfer function or characteristic polynomial. Characteristic polynomial. So for a system to be stable, for a system to be stable, for a closed loop system to be stable, the roots of characteristic polynomial should not be on the right hand side. That is, roots of denominator of closed loop transfer function should not be on the right hand side, or numerator of Q of S should not have any roots on the right hand side. All are same. So I am telling in three ways. One is roots of characteristic polynomial should not on the right hand side. Right hand side. The same can be said as roots of denominator polynomial of closed loop transfer function should not be on the RHS. The same can be said roots of numerator polynomial of Q of S should not be on the right hand side. All are same. All the three statements are same. Roots of characteristic polynomial should not be on the right hand side for a closed loop system to be stable. Roots of denominator polynomial of closed loop transfer function should not be on the right hand side. That is also same. Roots of numerator polynomial of Q of S, because roots of numerator polynomial is nothing but characteristic equation. Characteristic equation. So if you do the mapping for 1 plus G of S H of S, if you do the mapping for 1 plus G of S H of S by selecting the contour such a way that that contour encloses the entire right hand side plane, so that if any point on the right hand side is roots of that characteristic polynomial, then it will encircle the origin. It will encircle the origin. For example, I am taking the contour like this. Up to j infinity, I am selecting. This contour, its radius is infinity. It varies from plus 90 to minus 90. Then we are taking this part. This segment is called C1. We are doing mapping for C1. Then we are doing mapping for C2. Then we are doing mapping for C3. If you do this contour, if any of its roots on the right hand side, it will encircle in the clockwise direction once, because 0 means it will in the same direction. We are doing mapping for Q of S, not the transfer function. That's why if it encircles in the clockwise direction once, therefore one pole is on the right hand side unstable, because the contour is the entire right hand side plane. The contour is entire right hand side plane. Suppose two poles on the right hand side means it will encircle in the origin twice in the clockwise direction. S minus 1, so that it will be simple. S minus 1, stable system or unstable system? Open loop unstable system, because pole is on the right hand side. If you draw, where is the pole? P1 equal to 1 plus 1, therefore unstable system. What is the root locus? This is plus 1. The root locus will be like this. It will be it will cover the entire, if you k equal to 0 here k equal to infinity. This is the root locus. But if you increase k, after some time it becomes stable. Are you able to notice that? If you increase k, it becomes stable. In closed loop, it becomes stable. In open loop, it is unstable. Open loop, it is unstable, but closed loop, it is stable. Can you give any example for open loop, unstable, and closed loop stable system? Practical system. Bicycle or bike. If it didn't ride, stable or unstable? Unstable. If it didn't ride the cycle, it is unstable, it will fall. If you ride, it is closed loop system. What you are doing is, you are adjusting this side or that side. That's why you are turning the handlebar. To turn the cycle this side, suppose if it is falling this side, means you will turn this side. It means you are raising its level to vertical. If it falls this side, you are turning the opposite way. That's why it comes to again vertical. That's why if handlebar is locked, it will not, you cannot make it vertical. So in closed loop, it is stable. Open loop, it is unstable. Like that, this system is open loop unstable. This is open loop unstable. But in closed loop, it is stable. Let us consider this. What is the closed loop transfer function? T of S equal to, what is T of S equal to what? Closed loop transfer function is S minus 1 plus K. Am I correct or not? This is the closed loop transfer function. This is the denominator polynomial of closed loop system. Denominator polynomial of closed loop system. Find Q of S. Q of S equal to what? 1 plus K upon S minus 1 multiplied by 1. That is equal to what? 1 plus K by S minus 1. If you take LCM, you will get S minus 1 plus K. If you consider Q of S, that is characteristic polynomial. Q of S means characteristic polynomial. The closed loop denominator polynomial becomes numerator of Q of S. That's why it should not encircle the origin in the clockwise direction. It means it has some poles on the right hand side. Okay, now you understand. But there is no change in the denominator. You notice that there is no change in the denominator. So if you do the mapping for this, with considering the entire right hand side plane, this plane is called, this contour is called this Nyquist contour. Nyquist contour. Nyquist contour is in which plane? S plane. Nyquist contour is in S plane. I am taking a Nyquist contour and do the mapping. If I do the mapping, Q of S is what? S minus 1 in the denominator. That's why if you do the mapping, one pole on the right hand side. But here, no poles are, no zeros on the right hand side. No zeros on the RHS. Let us assume. No zeros on the right hand side means stable system. Am I correct or not? Because numerator is closed loop poles. Numerator of Q of S is closed loop poles. That's why no zeros on the right hand side of Q of S. It means no closed loop poles on the right hand side. But denominator one pole on the right hand side. That's why the mapping will encircle 0 in the anti-clockwise direction once. Now I can say that system is stable because it is not cancelling. No poles on the right hand side. Only one pole in the no zeros on the right hand side. No zeros on the right hand side. But only one pole in the open loop pole is on the right hand side. That's why it will encircle only once. Therefore, system is stable, I say. It means one open loop pole is on the right hand side. That's why this encirclement. Suppose two poles on the right hand side. Two open loop poles are on the right hand side, but no zeros on the right hand side means it will encircle twice in the anti-clockwise direction. Again, it is stable. Suppose if I am taking a stable system, I think you understand this or once again shall I tell? What is this? G of S equal to K upon S minus 1. This is open loop stable or unstable? Open loop unstable. What is the characteristic polynomial? S minus 1 plus K. For some values of K, the poles will be on the left hand side. Because if you see the root locus, if you K increase, it comes to the left hand side. We know that some K values of K, it will become a stable system. So, for a particular value of K, I want to check the stability. So, I am drawing the root locus for closed loop system. That's why I mapped the entire right hand side plane with Q of S. If you see that, the numerator of Q of S is the characteristic polynomial. That's why the roots of characteristic polynomial should not be on the right hand side. No zero should be on the right hand side. No zero should be on the right hand side. It should not encircle in the clockwise direction. But it will encircle once in the anti-clockwise direction. Why? Because the denominator of Q of S is S minus 1. That is fixed. One pole is on the right hand side. One open loop pole is on the right hand side. That's why it will encircle only once in the origin. Therefore, the system is stable. Suppose it is not encircling. What is the meaning? If it is not encircling, what is the meaning? It means some zero is on the right hand side getting cancelled. That's why it is not encircling. It is not encircling. Therefore, the system is unstable. Therefore, the system is unstable. Suppose it comes like this. It is not encircling means it should encircle for open loop. For closed loop, it should not encircle. Therefore, the open loop must exist here. That is, in the anti-clockwise, it should exist. It doesn't exist. Therefore, unstable. Suppose I am having on the other hand, I am taking a stable system. Suppose I am taking a stable system. Then what happens? Let us see.